Whenever we let ourselves dream about space, we dream about arrivals. Wheels touching down on Mars, a probe sinking through the ice of Europa, the next world we might map, orbit, or one day walk across. It's the exciting part, and it's where every documentary tends to point the camera. But there's a quieter question hiding underneath all of it, one that almost never gets asked out loud. Not where we're going, how long the trip actually takes, and the moment you take that question seriously, something uncomfortable surfaces. The trouble with space isn't only that it's enormous, it's that it's empty. The nothing that sits between one interesting place and the next is so wide that the journey itself becomes the real story, a story that quietly rewrites what the word exploration is even allowed to mean. So today we're going to time two trips. The first is to Pluto, the most famous world at the far edge of our planetary neighborhood. The second is to Proxima Centauri, the nearest star to our own sun. Both are real destinations. Both are, in principle, reachable. And the honest answer to how long is going to sit with you for a while. These numbers are not here to comfort you. They're here because they're true, and because once you feel them, the night sky stops looking the same. People love to call Pluto the edge of the solar system. Strictly speaking, that's not right. The Sun's family of objects reaches far, far beyond it. But by any human measure, Pluto is genuinely remote. It circles the Sun at an average distance of about 5.9 billion kilometers, roughly 40 times farther out than Earth. That figure is almost impossible to feel, so let's borrow the fastest thing in existence to measure it. Light moves at about 300,000 kilometers every second. Nothing beats it. Sunlight crosses the gap to Earth in about 8 minutes, quick enough that flipping a switch feels instant, even though it never truly is. That same beam of light, continuing outward, needs about 5.5 hours to arrive at Pluto. Sit with what that means. If the Sun were somehow switched off, we'd be in the dark within 8 minutes. Out at Pluto, the news wouldn't arrive for another 5 hours. Long enough for us here to grieve, make phone calls, and start bracing for what came next, all before the shadow even reached that distant world. And from Pluto's surface, the Sun no longer looks like the fierce disk we know. It shrinks to a single brilliant point. Still, correcting a myth you'll often hear, roughly 300 times brighter than a full moon is to us. Bright enough to read a book by, like the last glow of dusk, but it throws almost no heat at all. Standing there, you'd have light without warmth in a cold so complete it's hard to picture. If we wanted to reach that frozen point of light, we've already tried once. In January 2006, NASA sent a spacecraft called New Horizons toward Pluto, hoping to become the first mission ever to photograph it up close. New Horizons carries a specific record. It left Earth faster than any spacecraft in history, not the fastest object ever, since the Parker Solar Probe now whips around faster using the Sun's gravity, but the fastest at the instant of departure. Within about 9 hours of launch, it had already shot past the orbit of the Moon. The Apollo crews, by comparison, needed 3 full days to cover that same stretch. Its speed at that point was around 58,000 kilometers per hour. It is, by every human standard, absurdly fast. So how long did this record-setting machine need to reach Pluto? Almost 9 years. New Horizons lifted off on January 19, 2006, and made its close pass of Pluto on July 14, 2015. The fastest launch we have ever managed still spent nearly a decade simply crossing our own solar system. That single fact should reset your instincts. When people casually imagine humans visiting the outer planets, they're picturing something that, with today's tools, swallows the better part of a working lifetime just to arrive once. Here's the part that surprises most people. New Horizons never actually stopped at Pluto. It couldn't. To slow down and slip into orbit, the spacecraft would have needed to haul an enormous load of fuel, but fuel has weight. A heavier ship needs still more fuel to move it, which makes it heavier again, which demands more fuel yet, a punishing loop that engineers call the tyranny of the rocket equation. Braking, out there, is far harder than going. So, instead of arriving, New Horizons simply rushed past. It skimmed within about 12,500 kilometers of Pluto's surface, gathering everything it could in an encounter that lasted only hours, photographing the terrain, reading the temperatures, sampling the thin air, and then it kept right on going, out into the dark, never to circle back. And here the distance turned cruel in a second way. Pluto was so far off that a command from Earth needed about 4.5 hours just to arrive. Real-time control was impossible, so the whole make-or-break encounter had to be loaded into the spacecraft's memory beforehand and run entirely on its own, while the team back home sat waiting, unable to nudge it, unable to fix anything, not even knowing whether it had survived until the confirmation signal finally crawled back hours later. The most important few hours of the mission happened with everyone on Earth watching blind. Today, that spacecraft is roughly 10 billion kilometers from Earth, about 64 times farther from the Sun than we are. Only the twin Voyager probes, launched decades earlier, have ever traveled deeper. A radio signal from it now takes around 9 hours to reach us. We got our close-up, but it was a single glance out a car window at highway speed, not a visit. And that glance revealed something no one expected. Before the flyby, most scientists assumed Pluto would be a corpse, cratered, motionless, unchanged for billions of years, a dead rock at the bottom of the solar system. It is nothing of the kind. Pluto has mountains, some rising as high as 3.5 kilometers on the scale of the Rockies, but these peaks aren't stone. They're built from water ice, which at Pluto's brutal surface temperature of about minus 233 degrees Celsius is frozen so hard it behaves exactly like rock. There's also a vast, heart-shaped glacier of frozen nitrogen, wider than Texas, and across a huge stretch of it, a region called Sputnik Planitia, there is not a single impact crater to be found. That absence is the whole story. Everywhere in the solar system, surfaces slowly collect craters as debris rains down over the ages. A surface with none is a young surface, or one that keeps renewing itself. Something on Pluto is smoothing the scars away. Something is resurfacing the ground. Billions of kilometers from any warmth, this little world is somehow still geologically awake. The nitrogen glacier itself may be the culprit. The images suggest it doesn't just sit there, it slowly churns. Great cells of ice welling up, spreading and sinking again over enormous spans of time, like a frozen conveyor belt endlessly repaving the surface. Its motion, so slow you'd never see it, and yet its motion on a world everyone had written off as inert. Stranger still, the evidence hints that a liquid ocean may be hiding beneath its frozen shell, kept from freezing by heat, left over from radioactive decay deep inside. To actually confirm that ocean, though, a single flyby will never be enough. You'd have to orbit, to linger for years and watch. NASA has studied exactly such a concept, a mission called Persephone, launch around 2031, arrive around 2058, after a cruise of nearly 28 years. A scientist who helped design it in their 30s would be nearing retirement by the time it slipped into orbit. That's the cost of doing Pluto properly, an entire career spent mostly waiting. Everything so far, Pluto, the 9-year crossing, the 28-year orbit mission, has stayed inside our own solar system. We haven't so much as touched the space between the stars, And that's where the scale stops being difficult and becomes something close to unreal. The nearest star to our Sun is Proxima Centauri, a small, dim red dwarf bound into the Alpha Centauri triple star system. It sits about 4.25 light-years away, roughly 40 trillion kilometers. Try this comparison. Proxima is around 6,800 times farther from us than Pluto is. If Pluto were the fence at the back of your yard, Proxima would be in another city entirely. One you'd have to fly to reach, and notice what light years quietly tells you. Even light itself, the absolute speed limit of the universe, the fastest anything can possibly move, needs 4.25 years to make that crossing. So, the quickest a greeting could ever travel from us to Proxima is over 4 years, with another 4 for any reply. There is no faster mail service in existence. That's the fundamental flaw. Before we've even talked about the far slower reality of moving actual mass. And it's not just any star. In 2016, astronomers confirmed a planet orbiting in its habitable zone, Proxima b, a world circling at just the right distance for liquid water to be possible. It doesn't get quite as much warmth as we do. The planet receives roughly 65% of the sunlight Earth soaks up. But that still places it firmly in the zone where an ocean could survive. It is the closest potentially Earth-like world we have ever found. Most exoplanets sit hundreds of light years off, forever out of reach. This one is practically next door. So the obvious question, could we actually go? Here's the math, and it's merciless. At the speed New Horizons managed, the fastest we've ever launched anything, the trip to Proxima Centauri would take about 78,000 years. Let that number breathe. All of recorded human history, farming, the pyramids, every empire, every war, the entire space age, fits inside roughly 10,000 years. To reach the nearest star with our best existing engine, we would need to keep a mission alive and working for nearly 8 times longer than civilization itself has existed. That isn't a voyage, it's a span of geological time. To cross that gulf inside a human life, say 40 or 50 years, a ship would have to fly at around 10% of the speed of light. That's roughly 108 million kilometers per hour. Not twice as fast as New Horizons, not 10 times, close to 2,000 times faster. Engineers have sketched a few ways to try. Nuclear pulse propulsion, riding the shockwaves of small atomic detonations set off behind the ship, could, in theory, reach 3 to 5% of light speed, cutting the trip to perhaps a century or two. Fusion engines, like the 1970s Project Daedalus study, might touch 10%, trimming it to 40 or 50 years. Though the ship would weigh around 50,000 tons at launch and burn through a fuel, helium-3, that we still can't produce. Antimatter, the most extreme option, could in principle push toward 40% of light speed and a journey near 10 years. But making a single gram of it with today's machines would take roughly 1 billion years of non-stop effort. The most realistic near-term idea gives up on big ships altogether. It's called Breakthrough Starshot, backed by more than $100 million, and instead of one great vessel, it would fling out thousands of tiny ones, probes the size and weight of a paperclip, each carrying a miniature camera and radio. No onboard engine. Instead, an array of powerful ground-based lasers would hammer light against their sails, pushing them toward 20% of light speed, about 215 million kilometers per hour. At that pace, Proxima sits just 20 to 25 years away. Add the 4 years for the signal to travel home, and images from another star could reach us within about 3 decades of launch. Not a fantasy for our descendants, something people alive right now could live to see. Many of those tiny probes would die on the way, torn apart by specks of interstellar dust that, at such speeds, strike like bombs. But launch thousands and enough survive. It's exploration by sheer redundancy. And crucially, none of it demands new physics. It's brutally hard engineering, not magic. Line the numbers up, and a strange kind of hope appears alongside the humility. Pluto, 9 years to glance, 28 to stay. Proxima, 78,000 years the old way, maybe 30 with sails that don't yet exist. A century ago, the moon itself was pure fantasy. 50 years ago, we walked on it. Today, we're seriously drafting a probe that could photograph another sun. We may never stand on a world orbiting Proxima Centauri, but we just might live to see the first picture arrive. A message carried across the dark, proof that we finally reached beyond our own star. The distances are staggering, but generation by generation, patiently, we are learning to cross them. Subscribe, and be here when we take the next step outward. We've measured how far Pluto sits at the edge of the Sun's family, but almost no one stops to ask what lies in the other directions. What's directly above the solar system? What's beneath it? The answer wraps around us on every side. Watch what exists above and below the solar system to find out.